Good morning, children. Welcome back to our maths session. Today's topic is Introduction Part 2 of Lesson 5 Data Handling. In today's video, we are introducing representing data using graphs and different kinds of graphs that are bar graph, line graph, pie chart, a circle graph, and a double bar graph. With that, we are try these questions of page number 71. 3 questions are there. That also we are solving with this video. Okay, so let me start.
Now let us understand how data is represented using graphs. So where do you get to see these kind of graphs? Now as I gave some examples in previous slides, what happens when a teacher asks the favorite fruits to each student inside the classroom, then we can see that so many students gave the answer properly, isn't it? But they gave a better way of representing this data is by making use of a graph. Let's see. So this is a graphical representation of this data. Looking at this graph, you can very clearly say that how many students like apple. So how many students like apple? Here 50 students like apple, isn't it? Yes, right. How many like mango? That is 40. 30 of them like grapes, isn't it? And some around 20 of them like bananas. So just looking at this graph, you can easily say how many of them like each fruits and which is the most liked fruits in the entire class. Right? I mean, which is that fruit liked by most of the students in the class. So this is how graphical representation of data looks like. You might have come across newspapers which give weather reports in the form of graphs, isn't it? These graphs not necessarily always look like this. The graph could also look like a circular graph. It could also be a line graph. So there are many different kinds of graphs. So basically these are some of the scenarios where you said to see a lot of graphs are given. Now for people who maintain accounts, they also make use of graph when they want to analyze the data of the finance that they have. To see there if there is a growth taking place, or they want to see if there any decline in the finance. So they don't have places where graphs can be very crucial or that can be have very significance. Now what exactly is a graph? So a graph is nothing but a diagram that shows relationship between variable quantities. Now what is a variable quantities? Quantities which do not have a constant or a fixed value. So their values keeps changing. Now for example, as long as if we take the same example of favorite fruits, you see that as long as you ask two students, now one of them said apple is the favorite fruit and the second one said mango. The moment you ask the third student, what happens? Your data changes. And if the third student says that apple is his favorite fruits, so the number of students liking apple will change 1 to 2, right? So that means the number of students will likes apple, that is not fixed, keep changing the data, isn't it? So these kind of variable quantities, number of students keeping increasing or decreasing. Similarly, the number of students would like a particular type of fruits, so keeps changing. So they are variable quantities, isn't it? Changing the values. And when we have a diagram which shows the relationship between two variable quantities, that diagram is nothing but a graph. So let us take this example. Let's see that you have a car and this car is moving. Let's say the car covers a certain distance in certain amount of time. So let's say that this car, it covered 1 kilometer in the first 1 hour and again covered another 1 kilometer in the next 1 hour. It again covered 1 kilometer in the next 1 hour. So that is how the car is moving from one place to another. Now, can we represent this movement of the car using a graph? Yes, we can do that. So, let us say that we draw a graph. Now, what are the two variable quantities here? One quantity is distance because the distance is changing. The other quantity is time because the time is also changing. Right now, it might be 9 o'clock. Isn't it? The next moment it will be 9:05, again it will be 9:10, then 9:50, and so on. So the time is changing, and with the time the distance is also changing because the car is moving. So maybe at 9 o'clock the car might be at railway station, at 10 it might be at a school, by 11 it might be in a market, since the car is moving. So the distance covered by the car is changing with the time, isn't it? So distance and time are the two variable quantities, right? So let us say that we represent a distance on the y-axis and a time on the x-axis. Now if we say this is 0, this is the origin, then 1, 2, 3, 4, etc. And let us say that the time is representing in hours, okay, and so on. Similarly, here distance is represented in kilometer, then it's also like a 1, 2, 3, 4, and so on. Now, as per the movement of the car in the first 1 hour, that is, it covers 1 kilometer. So, 1 hour and 1 kilometer they need at this point. In the next 1 hour would be this much time, right? Next 1 hour it covers again 1 kilometer. That means this much distance, 2 in y-axis and 2 in x-axis. Isn't it? So basically it would be this point, right? Again in the next 1 hour it covers again 1 more kilometer. So this point will come here like this 3 and this 3 and so on. When we joined all these points together, what do you get? You get a straight line, right? So this straight line basically describes the motion of the car. That means it tells you that how the car is moving. That means the car is moving with a uniform speed. It is moving at the same speed, isn't it? That is every 1 hour it is covering 1 kilometer. If the speed and time is not in uniform, then you will not get a straight line. The line should be in change. So looking at the shape of the graph, you can determine the motion of that vehicle, right? So that is the point of a graph, that you no need to not manage huge, you have to, means a huge table is not required there, isn't it? The data and looking at the shape of the graph also you can analyze a lot of things, isn't it? So this is the advantage of a graph. Now in next slide we are going to study the different kinds of graphs.
Let's now talk about the various types of graphs. First one is bar graph. Bar graph is one of the most common type of graph. As you can see here what you have is, you have these kind of rectangular bars, isn't it? So this rectangular, each piece is called a bar, and that is why it is called a bar graph. And the height and the width of the bar is very important in a bar graph. It should be proper. The distance also should be same in between the bars. Okay. Now we can see the next type of graph. The next type of graph is a line graph. The one which we drew in the previous slide, right? You are remembering? Where you first note down the points and you join the points to make lines. And you can act the lines if it is growing or it is coming down, if it is remaining constant, that and all. Isn't it? You looking at the pattern of the lines, you can interpret the graph very clearly. So this is called a line graph. Now third type of graph. That is, the third type is a pie chart, which is also known as a circle graph. So it's a, let's see, when it's like a pizza. So when you have a pizza, cut a piece of or cut a slice of a pizza. So what is that? That is the slice will be either one fourth of the pizza, or it could be one sixth of the pizza, or it could be half of the pizza. So basically that part determine the fraction of the total amount of the pizza, isn't it? So in a pie chart, it is something like this. You have an entire pizza. In that entire pizza, you see that, okay, 40 percentage of it is for something, 60 percentage is something else, or you say 20 percentage is for something, 10 percentage is for something else, like a 10 is 10 percentage is again something else, and so on, like that, isn't it? So let's have you represented data in a pie chart. So look at this pie chart. Green, violet, red, and blue. Four different colors of the pie chart. Here you can see, isn't it? Represent four different objects. For example, in bar graph, you have different bars. Each of these bars represent each set of data. Here also, each part of the pie chart would represent each section of data. Now let us see how to be representing different types of graphs. So when it comes to a bar graph, now the beauty of the bar graph is that you have actually drawn a rectangular bar for each set of data. So when we look at the rectangle, the bar is the highest. Yeah, the bar is the height of the rectangle. The height of the rectangle actually gives us the value on the y-axis. For example, in this case, if we are drawing a bar graph for number of students versus their favorite fruits, isn't it? So what do we say? Fruits are taken on the x-axis and the number of students are on y-axis, right? So the first bar's height shows the number of students who likes apple. The width of the graph basically tells the quantity, isn't it? Width, it is giving one quantity, that is in x-axis. And the height of the bar tells you the other variable quantity. So the width and the height of the bar gives you all the information pertaining to the data. Okay. Now when you try to draw the same data using a pie chart or a circle graph, you see here apple is in liked by 50. That means almost, in fact, more than half of the people. So here it seems to be 50. But what about banana? So you look at the violet color that represents banana. It's liked by 20 people, and grapes is liked by 30 people, and mangoes liked by 40 people, isn't it? So this is how you can represent the same data using a pie chart. As I say, in a pie chart, how you separate each set of data is just like as the slice of the pizza. Here, the biggest slice is for apple. That means apple is the fruit that is liked by most of the students, isn't it? The same data again can be represented by using a line graph. So, in line graph, what do? We do not draw the bars at all. Here also, we draw the x-axis and y-axis in a similar way as of in the bar graph, but we just mark the note of the points. That is the point corresponding to apple. That is 50 students likely here, isn't it? Similarly, for mango, give a point at 40. Same way, grapes put a point on 30 and banana on 20. And then we join those points to form a line. And this is called line graph. So these graphs help us to determine that how the growth is, or how the liking is, as the uh, fruits changed from apple to mango to grapes to banana. So normally line graph helps us to see the growth or declination of any variable. Clear? So this is the way how we are drawing different types of graphs. Now here we have completed three types of graphs, that are bar graph, line graph, and pie chart, yeah, circle graph. Okay. In next slide we can see double bar graph. Okay. So next topic is double bar graph. Now we might come across a situation where we want to represent two sets of data simultaneously. So that is why we make use of double bar graph. It is basically a bar graph, but instead of one bar, you have double bars. Now let us take this example. Let's consider the same example throughout to understand the concept. Okay. So let's say the number of students versus their favorite fruits. So this study or this data is being recorded in the year 2018. Now if you record the same data in 2019, that is in 2019 you do the same analysis of favorite fruits versus number of students, have data will change? Right, because in 2018, 50 of them liked Apple, but in 2019, maybe 30 of them liked Apple. So number would change this time, isn't it? So now, if I say that I want to do a comparative analysis between these 2 years, I want to see how the likings for the particular fruit increased or decreased. Now, the moment we talk about comparative analysis of two sets of data, in that case, we will have to represent those two sets of data in a same graph. Only then we can compare it, isn't it? Only then it will be a comparison to apple, right? So that is why we are using double bar graph. And the double bar graph looks something like this. Here also we draw the same x and y axis, but here you see instead of one bar, you have two bars. So one bar, those represented in blue color, is for 2018, and at the other bar in red color is for 2019. Now, looking at this double bar graph, you can very clearly say that the likings for each of the fruits have decreased from 2018 to 2019. That means with the passage of time, the likings for fruits is decreasing or reducing, isn't it? So this is an example of a double bar graph. So double bar graph is exactly the same concept that of a bar graph. It is just here we represented two sets of data. So, have what are the two sets? One set of data is for 2018, the other set of data is for 2019. Now, what is the importance of double bar graph? The first important is that it helps in comparative analysis. You see, since we are able to plot the graphs for the 2 years in the same graph, so it helps us to compare how things changed from 2018 to 2019. So this helps us to analyze that the likings of each fruit has decreased in 1 year, and the maximum decrease happened in case of apple. Because when you look at the decrease of apple, you can see that the difference is maximum in apple. The decrease is lesser in mango. The decrease is even very small in grapes. It is also quite small in case of banana, isn't it? But in case of apple, the decrease is maximum. That means the liking for apple has reduced the most in 1 year. So all these kind of interpretation is become easier with a double bar graph. So that is why we are drawing, yeah, we are using double bar graph. So in one graph we can put two, yeah, more than two also we can show, but here double bar graph is the name, so that is why we are comparing two analysis, yeah, two sets of data. So what is double bar graph? Double bar graph means it's showing two sets of data simultaneously in one graph. Clear? Now we can solve some try these questions. Okay. So page number 71, first question. Draw an appropriate graph to represent the given information. You have to use your graph book, graph notebook, and draw it in graph notebook. Okay. So here the information is given. The number of watches sold in the month of July, August, September, October, November, and December. In July, 1000 watches sold. In August, 1500. September, 1500. October, 2000. November, 2500. And December, 1500. Okay. So first draw X and Y axis. X axis you can put the month, and Y axis number of watches sold. Now this way you can draw the graph. Okay. Now try the second question. Children who prefer walking and cycling. Both are given. Three schools are given. School A, School B, and School C. And here it's a double bar graph, isn't it? Two data are given. We have to represent both the data in one graph. So it's a double bar graph. So the answer you can see in x-axis we have mentioned the schools. School A, school B and school C. Walking, light blue color and dark blue color cycling. Okay. From this graph you can compare the children who are walking in school A, cycling is more than walking, but in school B, walking is more than cycling, and in school C, cycling is more than walking, isn't it? So like this, we can analyze here, we can compare the data. Okay, so this is a double bar graph. So draw it also in your graph book. Okay. Now let's see the third question. Draw an appropriate graph to represent the given information. Percentage wins in OD1 by 8 top cricket teams. So here from Champion Trophy to World Cup 6 and last OD in 2007. Okay. So South Africa 75 percentage, in 6 and 7 78 percentage, Australia 61 and in 47, Sri Lanka 54 and 38, New Zealand 47 and 50 percentage, England 46 and 50 percentage, Pakistan 45 and 44, West Indies 44 and 30, and India 43 and 56. So here also we can see that two data are given, isn't it? So we have to represent both the data in one graph. So that means we have to draw a double bar graph. So let's see the graph. So this is the graph represented by the information given in the question. Okay. So first bar is represented for Champions Trophy in World Cup 6. And second one is last 10 OD1 in 2007. Okay. In x-axis we have given the name of the countries, and in y-axis percentage runs. Run of percentage is given there. Okay. So you have to draw properly in graph notebook. Clear? Okay. This session we are winding up here. Okay. So thank you.